Let's step up the difficulty a little bit and make it a little bit more advanced. Now we're moving into a realm where you're going to do less of this because the more advanced things will be used slightly less, at least at first. But Boolean operators allow you to create complex expressions. And Boolean operators are not like Boolean data types, although they have the same origin, which is Boolean logic, okay? So that's why the common name. So Boolean operators include the words and, or, and not, okay? And so here's how they might be used in a scenario. We might have something like this. Now, this still evaluates to either true or false. But when I have the word and in there, this has to be true and this has to be true in order for the whole thing to be true. So give me a number value for x that would make this true. What'd you say? 4. 4 would make this true because 4 is greater than 2 and also less than 10. Any number that's greater than 2 and less than 10, so between 2 and 10, not inclusive, would make that true. Now, or is different. Or says only one of these has to be true. So if it's greater than 12 or it's less than 10, then it's true. Tell me what integer will make this not true, make this false. 11, because 11 is neither greater than 12 and it's not less than 10. Any other integer other than, actually, the whole truth is 10, 11, and 12 would all be false because it's not inclusive of those numbers. If it was greater than or equal and less than or equal, then only 11 would work. But 10, 11, and 12 would all produce false on this. Every other number imaginable would be true. Okay? This is the same as saying x exclamation point equal sign 5. So any number other than 5 as the value of x would be true. So as long as x is not equal to 5, it's true. So now we start to really get into some brain benders. And Boolean logic can do this to you because it can be incredibly complex. Tell me a value that will make this true. Think about this one and flip it. So this one, there were 3 values that won't work. In this one, there are 3 values that will work. 10, 11, and 12 would all be true here because it's not greater than 12 or, right, less than 10. So the not and the or are kind of a pain. So if we do x is not equal to 0 or x is greater than 10, so as long as x is not 0, it'll work. These are not mutually exclusive categories. If I say x equals 0 or x equals 10, either x has to equal 0 or it has to be a greater number than 10. So if I say x equals 0, it will print. If I say x equals 20, it will print. But if I say x equals 2, it will not print. So now if I say something like this, what value of x will work here? It doesn't exist because x can't equal 0 and also be greater than 10. But notice, PyCharm doesn't flag it here. If I have a regular condition that is impossible, is always going to be false, Python usually tries to flag it for me, but the Boolean logic makes it more complex. So you got to be really careful. And when you're using Boolean logic, you want to make sure that you're not putting yourself in an impossible situation. You have to ask, under what circumstances could this be true? What numbers would work here? And then you'll run into that problem less.